Very good evening, all. Very good evening. Very good evening, all. Yeah. So, is everything fine? Very good evening. चलो चलो सही चल रहा है, कोई प्रॉब्लम नहीं. Yeah. So let's start. Everything fine? Very good evening. चलो चलो सही चल रहा है, कोई प्रॉब्लम नहीं. No problem, no problem. Let's start. Lokesh, Soumyadeep, ऑडियो वीडियो क्लियर, ग्रेट. और क्या? सच्चिदानंद, आज नए नए आ गए देखो. चलो लेट्स स्टार्ट. इसको कैसे रखेंगे सर जी? चलो. सो वी स्टार्टेड साइक्रोमेट्री एंड एक सेकंड, इसका वॉइस कम कर दूंगा. I'll reduce the voice. Please, it's a request to all of you. If you are really serious, join on time. Otherwise, don't join. See, if you are really serious, join on time. Otherwise, there is no need to join. See, we have come here to learn something, and we are. See, if you want to do something great and big in life, you have to be disciplined in life. So if there is no discipline in life, you'll be in problems. So the first and foremost thing is discipline in life. Chalo, with this, we'll start the next class. That is last class we have seen what exactly is specific humidity. Then we have also seen what is relative humidity. And today we'll see dry bulb temperature, wet bulb temperature, dew point temperature. What is the relationship between all these three? What is exactly the physical meaning? What are they representing? And why do we need three temperatures? Is just one temperature not enough? All these things we'll be saying. Chalo, let me put my mobile in silent mode. So Raghavendra आ गए, अमित आ गए, हिंदुस्तानी भाव, वाह, रोहित बाबू आ गए, अदिति गुप्ता, और कौन है? कमंडलनाथ का है, सच्चिदानंद रूपाय. चलो, now, so can you see this, sirs? Like, can you see two thermometers? एक सेकंड मैं ऐसा दिखाऊंगा आपको. Yeah. So let me show you very clearly here. So here we have one temperature. This is actually representing dry bulb, and this is covered with a cotton cloth. That is, it is wetted, and this is wet bulb temper. It will measure wet bulb. Today we'll see all these things. Okay, चलो. चलो, let's proceed, sirs. Now, can you see? दिखा आपको? Have you seen? चलो. Hope it is clear. Good evening, Himesh. Good evening. Rohit, yes. अब ज्योति प्रकाश, ज्योति बाबू, गोविंद मुरारी, गोविंद बोलो, हरि गोपाल बोलो. क्या लेके आयो जग में, क्या लेके जाएगा वो बंधु. चलो, now let us see the third parameter, and that is, so what is the topic that you are discussing? Psychrometry. My sequence is something like this, and the first class will be deleted tomorrow. So after every second day, the class will be deleted. So this class is available for 1 or 2 days, then it will be deleted. Please, अब ये मेरे से मत बोलना ऐसा क्यों कर रहे, why are you doing all these things? It's our will and wish. Clearly मैं बता रहा हूं. तो जब आपको something, if you want something, a great concept and good content, and you should be disciplined. You cannot get at your convenient time. Okay, चलो. Now, let's see. See, कल हम देखे थे. Yesterday we saw what is omega and what is phi. Today we'll start with the third parameter, that is dry bulb temperature. Let me write this as dBT. So I'll designate this with simply T, dry bulb temperature. Dear students, daily you might be seeing in newspapers and watching on TVs, today's temperature is so and so, 30 degree, 34 degree, so and so. Daily you may be seeing in news. So this is nothing but your dry bulb temperature. So how do I define dry bulb temperature? It is the temperature of normal air measured by an ordinary thermometer. So you take one thermometer and this is the bulb. Now allow air to flow over this. Whenever I say air, can you tell me what is that air? It is a moist air. So this air also has water vapor. Allow air to flow over this and please see that nearby there is no moisture. I'm not talking about moisture in air. I'm not talking about it. Nearby artificially there is no moisture, and it is this thermometer is also away from solar radiation, so that the influence of that solar radiation is not felt on this temperature. So you just take a thermometer. Allow air to pass over this, and once the equilibrium is reached, our thermometer will record one temperature, and that we call it as dry bulb temperature, which is simply the normal temperature of air. So dry bulb temperature is simply the normal temperature of air measured by an ordinary thermometer. Great. Now, the question that comes to our mind is, why do we need different temperatures in psychrometry? So we have some more temperatures like wet bulb and dew point temperature. So before I explain what exactly wet bulb temperature is, let me ask you one question. And please answer to this question. I'll be checking your comments. My dear students, I am at Bombay, chalo Mumbai, and you are at Delhi. Listen carefully. Here the dry bulb temperature at Bombay is 30 degrees centigrade, and the dry bulb temperature at Delhi is also 30 degrees centigrade. Let me repeat, sirs. I have taken two separate locations. Now I gave you temperature at two different locations. At Bombay it is 30 degrees centigrade, and at Delhi it is 30 degrees centigrade. Now can you tell that the quality of air is same at both places? This is my question. Answer to my question. Can I say that the quality of the air, matlab, will you feel the same comfort at the same temperature? My question is, are you feeling the same comfort? Like you are at 30 degrees centigrade in Bombay, you are at 30 degrees centigrade in Delhi. Are you feeling the same comfort at that temperature? Oh, I got so many answers. Thank you. No. Why, sirs? Dear students, there is one term known as humidity, which is playing a vital role. At some places humidity may be more, at some places humidity may be less. If the humidity is more, generally at coastal places, as the evaporation is more, the humidity is more, so therefore you are not comfortable. Why are you not comfortable? If the humidity is large, so my air has more water vapor, it cannot absorb your moisture. So whatever the moisture is formed on your body, it will stay. So you have sticky sensation. So please note down that a single temperature is not enough to give the quality of air or to tell the comfort, like what comfort are you feeling just with a single parameter. Now the question that comes to our mind is, Sarji, yesterday you gave two parameters related to humidity. One is specific humidity, one is relative humidity. So if this temperature is given, then I will specify relative humidity. If this temperature is given, I'll specify the relative humidity, then the problem will be solved now. Why do we need one more temperature? Answer to my question, sir. So if the temperature is given, that is dry bulb temperature, dry bulb se confuse mat hona, it is normal temperature of air. Take a thermometer, expose to air, find out the temperature, that will be dry bulb temperature. That's it, nothing more than that. Now, dekhiye sirs. Now, let us say I am giving you the relative humidity. Definitely relative humidity or omega. Out of these two, anyone I'll give you, or both. It is enough. It is enough for me. Yes or no, sirs? When I gave you temperature, Apart from that, one more parameter that is relative humidity I am giving you. One more parameter that is relative humidity. It is showing the moisture content. So let us say I am giving you omega. What is omega? It is actual mass of water vapor in air. So I am giving you omega, I am giving you temperature. That is enough. Absolutely enough. Now the question that comes to our mind is, sir, already we defined omega, already we defined phi, now you have defined temperature, so single parameter is not enough. So we apart from temperature, I'll give you relative humidity or omega. That is enough. Yes, it is enough. Now the question is, if this is enough, why do we need one more temperature? Great question, sirs. Are you getting my point, my dear students? What I am saying is, if the value of omega, if values of omega and temperature are given, it is enough. I know what is actual omega, what is the actual temperature. With this, I can tell what the person is feeling. I can tell there is no problem. Enough. Two parameters are enough. But if two parameters are enough, then why do we need remaining temperature? Can anyone tell, sirs? Can anyone tell? I said clearly, already we defined phi omega, and today we have defined temperature, drivable temperature. So if two are given, that is enough to know. So let us say at Bombay the humidity is more, at Delhi the humidity is less. So therefore I can easily tell what comfort the person is feeling. Then why do we need to define one more temperature, that is wet bulb temperature? I am looking for your answers. I am looking for your answers. To generalize. What do you mean by to generalize? नहीं sirs. So आपको क्वेश्चन समझ में आया सर जी? So daily I'll be taking psychrometry class at 7:30, and don't expect me to tell daily. Daily I'll be available on this channel, that is Mechanical Ka Funda. So I'll be taking class daily. I'll not, matlab till I complete psychrometry, except Sunday. Okay, now to generalize variable, no sir, no sirs. Now I'll tell you, my dear students, it is difficult to measure the relative humidity and omega. It is difficult to measure relative humidity and omega. Is it easy to measure dry bulb temperature? Yes, it is easy to measure dry bulb temperature. But it is difficult to measure phi and omega. There are devices, sir. We call it as hygrometer. This hygrometer is used for measuring relative humidity and omega, but it is very difficult to measure phi and omega. That's why there is a proxy. अरे यार एक स्टूडेंट आपका फ्रेंड क्लास में नहीं आया तो उसके प्लेस में दूसरा अटेंडेंस देता है. वी कॉल इट एज प्रॉक्सी. तो ये नहीं आ रहा है क्लास में, इट मीन्स इट इज वेरी डिफिकल्ट टू मेजर दिस क्वांटिटीज. तो इसके प्लेस में नया खिलाड़ी उतर रहा है, दैट इज वेट बल्ब टेम्परेचर. इन इंटरव्यूज इफ they ask you why do we need one more temperature, already we have, so you may be saying, sir, wet bulb temperature it will indicate moisture, all those, but for indicating moisture already relative humidity omega is there na, why do you want wet bulb temperature? Then your answer should be, sirs, already omega and phi are there, but those values are very difficult to find. That's why, so in place of this, an easy way to measure is wet bulb temperature. Right now we don't know what is wet bulb temperature, so it is an easy, ये भी thermometer है, so like dry bulb temperature, it is also measured by a thermometer. It is very easy to measure. Once that is known, everything is known. Is it clear, my dear students? Is it clear, my dear students? Is it clear, my dear students? अरे यार आप लोग कुछ नहीं बोल रहे, इतना अच्छा पॉइंट बताया आप लोग ना. Please, you people are, I'm sorry sirs, beauty not appreciated is a sin. Clear हो गया? Clear हुआ? Wonderful sirs, wonderful. Now let us see a beautiful concept of wet bulb temperature. Let's see the beautiful concept of wet bulb temperature. Wet bulb temperature, and we write this as WBT, and some textbooks designate it with T dash. T stands for dry bulb temperature. Dear students, T stands for, कहां गए रहे हो? हाँ, T stands for dry bulb temperature and T dash stands for wet bulb temperature. First I will define what it is. पहले मैं define करूंगा sir, what is wet bulb temperature. First I will define, then I will give you a physical feeling and what exactly it is representing. द वेट बल्ब टेम्परेचर का फिजिकल मीनिंग। अब एक बात देखो सर, बिफोर आई मूव माय डियर स्टूडेंट्स, बिफोर आई मूव, एक सेकंड, कहां गए रे, ओके, देखो, लेट अस टेक टीएस डायग्राम and this is the TS diagram. Whenever I draw this diagram, it is actually for what? It is actually showing the state of water vapor in air. It is actually showing the state of water vapor in air. For example, how is water vapor in air existing? Superheated state. I repeat, superheated state. It is existing in superheated state. And this temperature, dear students, let this be the state of water vapor in air. And you know, whether it is water vapor or dry air, both are existing at same temperature because they are in equilibrium. So if I show you the temperature of water vapor, it is also the temperature of dry air, it is also the temperature of mixture. So our dry bulb temperature is nothing but, it is actually temperature of water vapor, it is actually temperature of dry air, or it is also the temperature of mixture because it is in equilibrium. So I will write this temperature as dBT. And you also know that, so it has its own pressure, which we call it as partial pressure of vapor. So therefore, this is the partial pressure of vapor. So can you tell me what is this point representing? Anyone in the class, what is this point representing? It is actually showing the state of water vapor in air. For example, there is air here. You have some mass of water vapor, you have some mass of dry air. Let the partial pressure of dry air be PA. Let the partial pressure of vapor be PV. Let the temperature of vapor be TV. Let the temperature of dry air be TA. And you know, this is completely in equilibrium. When it is completely in equilibrium, temperature of dry air is equal to temperature of vapor is equal to temperature of the mixture. So that's what I have shown. वाटर वेपर हो या ड्राई एयर हो या कंप्लीट मिक्सचर का टेम्परेचर T है, एंड दिस इज अवर ड्राई बल्ब टेम्परेचर, दिस इज अवर ड्राई बल्ब टेम्परेचर. सो दिस इज द रिप्रेजेंटेशन ऑफ ड्राई बल्ब टेम्परेचर ऑन TS डायग्राम. Very good. Now let's move to wet bulb temperature. So is the represent, because let me represent everything on TS diagram, then I'll start comparing this. Very good, sirs. अब देखना sirs. Now, dear students, let's see what exactly is wet bulb temperature. पहले सुनो sirs. There is a thermometer, and this thermometer is covered by a wet cloth, cotton cloth, wet cloth. It is completely saturated with water. What does it mean? You take a cloth, completely soak, immerse in water so that it cannot absorb any more amount of moisture. That's why we call it as saturated. Now it is covered. Allow the air to flow over this cotton cloth, wet cloth. Now, you know, my dear students, let us assume that unsaturated air is flowing over this. What do I mean by unsaturated air? Anyone in the class, what do I mean by unsaturated air? The meaning of unsaturated air is, when air is flowing over this air has got capacity to absorb certain amount of moisture. At every particular temperature, it will absorb only certain amount of moisture. Beyond that, it cannot absorb. So when I say unsaturated air, it means it has some more capacity to absorb moisture up to till it reaches saturation. Means first I'll take unsaturated air flowing over the wet cloth, then we'll take saturated air flowing over the wet cloth. So dekho sirs, this air, is it unsaturated? Yes. When this point is on this line, we call it as saturated. We call it as saturated. So where is this point now? It is in superheated state, and that's why we call it as unsaturated, unsaturated, unsaturated. No problem at all. Now tell me, is that air which is unsaturated has a capacity to absorb some more moisture? Yes, it has a capacity to absorb some more moisture. Yes, it has got capacity to absorb some more moisture. अब हो क्या रहा है? What is physically happening? Let us see, sirs. थोड़ा 10 minutes तक forget everything and listen to me. It's a request. For 10 minutes, forget everything and listen to me. You know, my dear students, let me change the color. I'll take blue. Now this is completely water, so this cloth is completely immersed in water, and it is soaked, and it is completely saturated with water. What do I mean by cloth saturated with water? Pani, see, you take a cloth, immerse completely in water. अब वो और it cannot absorb moisture, water, so it is saturated. Now definitely this is all water. Can I say these are all water droplets? Can I say these are all water droplets? Yes, these are water droplets. Now which air is flowing? Anyone? Which air is flowing? Unsaturated air. You know very well that this air has a capacity to absorb some more amount of moisture. It has a capacity to absorb some more amount of moisture. Correct or not? Yes. अब देखो सर, moisture को तो लेना है. Who has to take that moisture? This air, unsaturated air has to take. If it is already saturated, will it take? Already आपका पेट यहां तक भर गया. Will you take some more amount of food? No. You will vomit. तो ये अभी यहां तक नहीं खाए, थोड़ा कम खाए. तो now you can eat some more ना. You can eat some more ना. Yes. अब देखो. Now look at sirs. Air is entering. Air is entering. होता क्या है? I'll tell you. The air which is, I'll show this blue is completely pani. Now the red one I am showing, this is also water. The red one is also water which is on the cotton cloth. So ये भी पानी है सर, लेकिन ये पानी कहां पे है? On the surface. On the surface. Don't get confused. ये भी पानी है, ये भी पानी है. This is water. This blue one is water. Red one is also water. But red one is at the surface. You know, surface molecules, they have higher molecular activity due to high translational energy. So they try to, मुझे बताओ सर, simple logic पूछूंगा आपको. There are molecules inside. There are molecules here. Which molecules have easy capacity, मतलब easily they can escape. Which molecules have tendency to escape? Look at, if these molecules, if they have to move, they have to overcome the resistance of all cohesive forces because it is surrounded by various corresponding fluids. So it has to overcome all. So it is not easy. But here above there are no similar molecules. So thereby surface molecules can easily escape. They can easily escape. So that's why these surface molecules, they escape from this. But for escaping, how can this water be added to unsaturated air? First, water should be converted into vapor, which we call it as evaporation. First, water should be converted into vapor. So for converting liquid to vapor, you need what energy? Latent heat. How can I convert water to water vapor? Have you ever observed? You take a small container, you place some water in that container and close the door and you go somewhere. After some time you observe that the level of water getting reduced because of evaporation, because the surface molecules have tendency to escape, which we call it as evaporation. So evaporation is a surface phenomenon. It can occur at any temperature. So why it is evaporating? मतलब देखो एक बार, तो अब कैसा evaporate होगा? The surface red molecules are getting attached to this air, unsaturated air. But how can I convert the surface molecules which is in liquid state to vapor? Someone should give energy. So initially, listen carefully, these surface molecules, they take from inside. When they take from inside, there is locally temperature drop. I repeat sirs, let me repeat sirs. मैं आपको बहुत ही अच्छी तरीके से बताने की कोशिश करूंगा. Please listen. Please listen, sirs. I'll try to teach this so beautifully. In interviews, you don't face any problem. Let me explain, sirs. Please listen, sirs. Please listen. ये है आपका thermometer. It is cotton cloth. Please 10 मिनट के लिए I request everyone to forget everything. Now, please understand, sirs. This is water. Correct? And what is this red वाला? Red वाला क्या है? Surface molecules. And these surface molecules are escaping. So this surface liquid molecules is converted into vapor. How is this liquid converted into vapor? You need latent heat. So that latent heat is initially provided by these inside water. तो inside water, तो जब वो heat लेता है, तो यहां पे locally temperature drop होगा. जब locally temperature drop होगा, हमारा एयर तो वही तलाश में था. It was in search of that only. When there is locally temperature drop, now it starts giving heat. So gradient is initially created from within. पहले temperature gradient कौन create कर रहा है? So my surface water molecules are taking energy from inside. अंदर से हीट लेने के बाद यहां पे लोकली टेम्परेचर कम हो रहा है. जब लोकली टेम्परेचर कम हो रहा है, अब एयर का टेम्परेचर ज्यादा है तो ये कम है, तो हाई टू लो, अब एयर हीट ट्रांसफर करेगा. When it transferring heat, why is air transferring heat? Because it wants moisture. So there is a simultaneous heat transfer, mass transfer, heat transfer, mass transfer. क्या ये बात समझ में आई सभी को? डियर स्टूडेंट्स, हैव यू फॉलोड? लेट मी एक्सप्लेन. मैं 1000 बार एक्सप्लेन करूंगा, लेकिन समझ के जाना प्लीज. लेट मी एक्सप्लेन. फिर से बताऊंगा सर. दिस इज थर्मामीटर. पहले वेट बल्ब टेम्परेचर क्या है देखेंगे. फर्स्ट वी विल सी व्हाट इज वेट बल्ब टेम्परेचर, देन विल सी इट्स फिजिकल सिग्निफिकेंस. फर्स्ट विल सी व्हाट एग्जैक्टली इज वेट बल्ब टेम्परेचर, देन विल सी इट फिजिकल सिग्निफिकेंस. फिर से बता रहा हूं सर. इट इज अ कॉटन क्लॉथ, वेट क्लॉथ. ये तो वेट क्लॉथ है. Now, listen sirs, this is all water and this is, देखो, अरे ये भी नमूना है, हाँ. अब देखना. Now, this is our surface water. हो क्या रहा है देखो. Now please understand. The surface water is taking heat from inside. अंदर से हीट ले रहा है, तो यहां पे locally टेम्परेचर ड्रॉप हो रहा है. When the temperature is dropping, now this will occur until there is a sufficient temperature drop. अगर sufficient temperature drop हुआ, अब unsaturated air आ रहा है. यहां पे locally the temperature has dropped down. Now it is low temperature, it is high temperature. Now air will give heat. Why is it giving heat? Because there is a temperature difference. Gradient is created. जब heat transfer कर रहा है, high to low, heat transfer कर रहा है, तो air का temperature drop होगा और वो humidity लेगा, moisture लेगा. So air, initially the gradient is created from inside. Once that low temperature is created, low temperature अब low होगा, air will give heat, take moisture. Air will give heat, take moisture. So there is simultaneous heat transfer, mass transfer, heat transfer, mass transfer. How long it will occur? Until it reaches saturation. And that saturation temperature we call it as wet bulb temperature. Let me represent. क्या ये बात समझ में आई सर सभी को? Dear students, have you followed, sirs? Dear students, have you followed? There is a simultaneous heat transfer, mass transfer, heat transfer, mass transfer, heat transfer, mass transfer. तो air अपना heat खो रहा है. So when it is giving heat, its temperature is dropping and it is absorbing moisture. जब moisture लेगा तो क्या होगा सर? समझ में आया सर? पक्का एक बार बोलो. See, I said ना clearly top of the world. Clearly I told you that initially locally the gradient is created. अब देखना सर, प्लीज लिसन. अब देखो सर, लेट मी ट्राई टू रिप्रेजेंट द सेम थिंग ऑन टीएस डायग्राम. इधर देखना. लेट मी ट्राई टू रिप्रेजेंट द सेम थिंग ऑन टीएस डायग्राम. बहुत अच्छा बताऊंगा सर, डोंट वरी. कैन एनीवन टेल व्हाट इज दिस टेम्परेचर? मैं कमेंट्स में देखूंगा आपका, ये कौन सा टेम्परेचर है सर. सो एनीवन, व्हाट इज दिस टेम्परेचर? ये कौन सा टेम्परेचर है सर? व्हाट इज दिस टेम्परेचर? एनीवन, व्हाट इज दिस टेम्परेचर? वंडरफुल सर, वाह, अब आएगा मजा. यस, दिस इज ड्राई बल्ब टेम्परेचर. नाउ हाउ कैन आई शो वेट बल्ब टेम्परेचर? बहुत केयरफुली सुनना. एयर इज लूजिंग हीट. When it is losing heat, what is happening to its temperature? Temperature is decreasing. But at the same time, देखो एक बार मैं आपको बताऊंगा सर. एक सेकंड रुको सर. Let us say this is temperature. तो अब सवाल यह है, it is a constant pressure line. Is the air losing heat at a constant pressure? Water vapor देखना. So it is absorbing water vapor. जब air heat दे रहा है, moisture ले रहा है, there is heat transfer, mass transfer, heat transfer, mass transfer. जब वो moisture ले रहा है, तो what will happen to the partial pressure of vapor? When it is, you know, PV is equal to mRT. When it is losing heat and taking moisture, जब moisture ले रहा है, तो क्या होगा सर? पार्शियल प्रेशर ऑफ वेपर वो बढ़ेगा. मींस when it loses heat, its temperature is dropping. It should move down. But मुझे बताओ सर, I will show you two pressure lines. Let us say this is P1 and P2. Which pressure is more? डेफिनेटली ये P2 है, ये P1 है। P2 ऊपर वाले का प्रेशर ज्यादा है, नीचे वाले का कम है, तो P2 इज ग्रेटर देन P1। इज इट क्लियर? इज इट क्लियर? इसका मतलब एयर इज लूजिंग हीट, तो उसका टेम्परेचर ड्रॉप करेगा, but at the same time it is gaining moisture. When it is gaining moisture, what will happen to the partial pressure of vapor? Vapor का partial pressure बढ़ेगा। इधर देखो, it is losing heat। देखो carefully देखो, अगर मैं सेम लाइन से दिखाऊंगा तो here partial pressure of vapor is constant, so it cannot be, because it is gaining moisture, तो vapor pressure बढ़ेगा। इधर देखो, now सुनो sirs, let me take another color so that you can visualize। इधर देखो, क्या ये सही है सर? एक पॉइंट दिखाना, क्या ये सही है? इधर देखना सर, प्लीज लुक एट दिस पॉइंट। What is the pressure of this point? Definitely compared to this pressure is more. Compared to this pressure is more. This pressure is more. This pressure is more. And compared to this temperature is less. It is losing heat, so its temperature is dropping. Temperature is dropping. It is gaining moisture, तो vapor pressure बढ़ रहा है. So it should follow this. It should follow. How long? Until it reaches saturation. And that particular temperature we call it as wet bulb temperature. नहीं आया सर? समझ में नहीं आया सर? आपको समझ में नहीं आया सर? मैं बताता हूं सर। Don't worry sirs, I will tell you. तो it is losing heat। देखो, losing heat, gaining moisture। देखो ऐसा आ रहा है, देखो why are you showing below? देखो what is happening here? ये टेम्परेचर है, what is this temperature? Anyone? इससे ये टेम्परेचर कम है, and what is the pressure here? Definitely compared to this pressure is more। तो ऐसा कहां तक हो जाएगा? Until it reaches saturation। So let me explain sirs, let me explain। So what is happening sirs? It is lose, एक सेकंड प्लीज, क्लियरली बताऊंगा सर, क्लियरली बताऊंगा। डोंट वरी, आई विल एक्सप्लेन 100 टाइम्स, डोंट वरी। उसके बाद फिजिकल सिग्निफिकेंस बताऊंगा। फर्स्ट लेट अस सी व्हाट इज दिस। ऑल ऑफ यू आर यू गेटिंग? ऑल ऑफ यू आर यू गेटिंग? नीतीश थैंक यू बेटा, थैंक यू। अगर समझ में आ रहा है तो कॉमेंट करो, समझ में आ रहा है। हाउ डू आई नो दैट वेदर यू आर फॉलोइंग और नॉट? इट्स नॉट एन ऑफलाइन क्लास ना। So okay, now देखो एक बार, let's see, देखो एक बार, please listen, this is our PV, partial pressure of vapor. What is this temperature? Absolutely it is dry bulb temperature. This is dry bulb temperature. Now air is losing heat, तो temperature घटेगा। Why are you moving like this? Because you just see what is the pressure here। इस पॉइंट पे प्रेशर क्या है? डेफिनेटली इसके कंपैरिजन में ज्यादा है। Why this pressure is increasing? Because it is gaining moisture। When it is gaining moisture, the partial pressure is increasing from PV1 to PV2। Let us say this is 1, this is 2। And why the temperature is dropping? It is losing heat। Why it is losing heat? In the process of gaining, तो मॉइस्चर लेने के लिए। Why it is gaining moisture? Because it needs moisture, because it is unsaturated ना। अगर saturated है तो वो केयर ही नहीं करेगा। So how long it is losing heat, gaining moisture, losing heat, gaining moisture? How long? Until it reaches saturation, and that temperature you call it as wet bulb temperature। Oh my God! When unsaturated air is flowing over the wet cloth, इसका मतलब for unsaturated air, this is unsaturated only and this is saturated। Dry bulb is more, wet bulb is less। Dry bulb is more, wet bulb is less। अरे बाबा, are we clear? My dear students, are we clear? अरे कुछ नहीं बोलते सर साहब। Is it clear? कुछ नहीं बोल रहे सर। Is it clear? Actually आप बोलेंगे सर, कैन यू गिव मी द फिजिकल फील ऑफ दिस? अब फिजिकल फील दूंगा सर। क्लियर सर? पक्का राघवेंद्र, गॉट इट। थैंक यू सर, थैंक यू। वाह, मजा आ गया रे, अब मजा आ गया रे, अरे रे मजा आ गया रे। देखो, लेट मी इरेज दिस। Now, have a look at this। अब मैं जस्ट पूछूंगा, आप आंसर दीजिए। बोलो, what is this temperature? It is dry bulb। What is this temperature? It is wet bulb temperature। For unsaturated air, dry bulb is more, wet bulb is less। एब्सोल्युटली फाइन, एब्सोल्युटली फाइन, नो प्रॉब्लम एट ऑल. थोड़ा फिजिकली इसका फील ले लेंगे सर. एक्चुअली देर इज वन डिवाइस नोन एज स्लिंग साइक्रोमीटर. This is our sling psychrometer. So there is one thermometer which measures dry bulb. There is another thermometer, it is called with wet cloth. Now I have an opening. देखो मैं आपको दिखाऊंगा. I have an opening. इधर देखो. I'll open it. देखो एक बार. I'll open it and और इसमें देखो. And in this is the cloth. So this is the cloth. You can see. I'll pour water completely saturated and I'll close it. देखो. I'll close it. Look at. अभी बताऊंगा. I'll close it. Now I have closed it. This thermometer is recording dry bulb and this is recording wet bulb. This is recording wet bulb. Okay. Now actually, so please क्या होता है ना? If I keep like this only, there is no free flow of air. So for causing the free flow of air, we rotate like this. We rotate like this. This is known as sling psychrometer. So after say for example half minute or so, you can easily record temperatures. Now I will give you the physical feel. Now I will give you the physical feel. सुनो सर. Shall we proceed? अब देखो आगे बढ़ते हैं सर. अरे बाबू रे ये हो गया. Now observe here. Let us take case 1. Let us take case 2. बहुत केयरफुली सुनना सर. अब आएगा ब्यूटी ऑफ वेट बल्ब टेम्परेचर. The dry bulb temperature is 30 and the dry bulb temperature is 30. With this information can I tell the quality of air? Is information say can I tell the quality of air? Nah. Let the wet bulb temperature be 28. I'm sorry sirs. Yes. There are two different places. Even though the dry bulb temperature is same, the wet bulb temperatures are different. What is this information signifying? ये information क्या बता रहा है एक बार देखेंगे. What is this information showing us? Let's see sir. Please understand. Can you tell me why the wet bulb temperature is lower than dry bulb? पहले ये visualize करना. Why both are unsaturated only. Okay. Can you tell me why the wet bulb temperature is lower than dry bulb temperature? आप बताइए. Why the wet bulb temperature is lower than? The reason is air is losing heat and gaining moisture. Why is it gaining moisture? Because it is unsaturated. If it is already saturated, will it take sir? अरे ऑलरेडी आपका पेट यहां तक भर गया, क्या फिर दोबारा खाएंगे? नहीं. As it is unsaturated, to reach saturation, it is देखो, it is something like quid pro quo. This is a technical term used by our advocates. Quid pro quo. You give me something, I'll give you something. तो ये क्या हो रहा है? Air is giving heat. In that process, air is giving heat and that is taking moisture. After giving heat, then only moisture is added. आप heat दे दो, मैं moisture दूंगा. आप heat दे दो, मैं moisture दूंगा. आप heat दे दो, मैं moisture दूंगा. You give heat, I'll give moisture. So it is something like quid pro quo. Dear students, if you observe these two values clearly, बहुत carefully सुनना सर. इट्स लाइक इधर देखो, मैं कुछ फिगर ड्रॉ करूंगा, आपको समझ में आएगा सर. दिस इज एयर विथ मॉइस्चर, दिस इज एयर विथ मॉइस्चर एंड दिस इज. अब देखो, अब देखना सर. इन दिस केस व्हाट इज द मॉइस्चर? इन दिस केस व्हाट इज द मॉइस्चर? लेस मॉइस्चर मीन्स लेस ह्यूमिडिटी होगा. यस. लेट अस से बॉम्बे के साइड जाओ तो कोस्टल एरियाज, चेन्नई, विजयवाड़ा, देयर द मॉइस्चर विल बी वेरी हाई. सो नाउ हियर लेट अस टेक, देखो यहां पे लेस मॉइस्चर, यहां पे मोर मॉइस्चर, समथिंग लाइक द कोस्टल एरियाज, मोर मॉइस्चर. देखो Here, high moisture. देखो sir, see the beauty here. If already the moisture content is more in air, will it absorb? What will be its absorbing capacity? If already the moisture content is high, what will be its absorbing capacity? मैं पूछ रहा हूं sir, if already the moisture content is high, will it absorb? If already the moisture content is high, what will be its capacity to absorb? मैं पूछ रहा हूं sir, पूछ रहा है भारत. तो already, yes, already its moisture content is high. Already the moisture content is high. So its capacity to absorb moisture will be less. So when it is absorbing less moisture, so अरे यार already air के पास बहुत ज्यादा vapor है. Already in air there is large water vapor. So when it has large water vapor, its absorbing capacity will be less. So when it is taking less moisture, it will lose less heat. Same thing ना, आप ये दे दो मैं ये दूंगा. मेरे पास already बहुत है, अब मुझे थोड़ा चाहिए. सुनो carefully. Already I have more moisture. यहां तक. तो मैं क्या करूंगा? थोड़े ही पैसे दूंगा, इतना ही बिरयानी खाऊंगा. So look at carefully. When already moisture is high in air, it will lose less heat to gain that to reach. आप बताइए, already its moisture is high. So I can say it is close to saturation. So when it is close to saturation, what will be its absorbing capacity? Less. जब वो कम absorb करेगा तो कम heat देगा. जब कम absorb करेगा कम heat देगा. क्यों? Because it wants only less moisture. So it will lose less heat. When it is losing less heat, what will be the drop in temperature? Less. जब drop कम है, नहीं आ रहा सर समझ में, मैं बता रहा हूं. What is the moisture content here? High. When the moisture is high, its absorbing capacity will be less. So when its absorbing capacity is less, it loses less heat to gain that less moisture. When it is losing less heat, there will be only small temperature drop. That's why from 30 there is only small temperature drop of 2 degree. So just 2 degree is enough to reach saturation because already it has more. Just this small drop is enough to reach. Already इतना है और कितना चाहिए? सिर्फ इतना saturation reach हो गया. So here you just observe. As the moisture content is less, its absorbing capacity will be more. So when it is absorbing more moisture, it has to give more heat. जब भी तो more moisture आएगा ना, when it gives heat, then only moisture will come now. So if the moisture is less, its absorbing capacity is more. But if it wants to absorb more, it has to give more heat. When it is giving more heat, there will be more drop. Corresponding to dry bulb, there will be more drop. What is the drop? 9 degrees. To reach saturation, this is the huge drop. इसका मतलब है wet bulb temperature is an indirect indication of moisture content in air. अगर air में moisture कम है, बहुत कम है, तो it will absorb more. When it absorbs more, it will lose more heat. When it loses more heat, there will be more drop. More drop in temperature signifies more absorbing. When it is absorbing more, its original moisture is less. That's why it is very far from saturation. That's why the difference is large. So wet bulb temperature is an indirect indication of moisture content in the air. If the difference between dry bulb and wet bulb, which is known as wet bulb depression, if the difference between dry bulb and wet bulb, which is known as wet bulb depression, is large, that means the moisture content air will be very less. If the difference between dry bulb and wet bulb is small, the moisture content in air is very high, it is close to saturation. Is it clear, my dear students? अजय यादव, थैंक यू बेटा. इज इट ठोको ताली, समझ में आया नहीं रे? सर आप कुछ नहीं बोल रहे. थैंक यू सर, अंडरस्टूड क्लियरली. वाह सर, आपके कमेंट्स नहीं आ रहे सर. मजा नहीं आ रहा. ब्यूटिफुली एक्सप्लेन. क्लियर? तो इन इंटरव्यूज इफ दे आस्क यू व्हाट इज वेट बल्ब टेम्परेचर, तो अब आप पूछो, क्वेश्चन पूछो. हम जब प्लस क्लास में करते ना हमारा कॉमेडी, अब बोलो, आप पूछो इंटरव्यू में, सर व्हाट इज वेट बल्ब टेम्परेचर. बोलो रे, बोलो, आप पूछो. अरे यार बोलो रे, क्वेश्चन पूछो. आप नहीं पूछते. देखो, आई एम आस्किंग यू आर इंटरव्यू बोर्ड मेंबर, आई एम स्टूडेंट. हाँ चलो, अक्षत ने पूछा व्हाट इज वेट बल्ब टेम्परेचर. मिस्टर कुलकर्णी, व्हाट इज वेट बल्ब टेम्परेचर. सर डोंट से इट इज कवर्ड बाय वेट क्लॉथ एंड इट इज, पहले ये सब मत बोलना. सर wet bulb temperature is an indirect indication of moisture content in air. if the moisture content in air is less, its absorbing capacity will be more. If the absorbing capacity is more, in the process of absorbing more moisture, it has to lose more heat. In the process of losing more heat, the drop in temperature will be more. So the difference between dry bulb and wet bulb will be more if the water vapor in air is very less. That means when the water vapor in air is very less, then the wet bulb depression, the difference between wet bulb and dry bulb will be large. And if the moisture content in air is very large, so it needs very less moisture to reach saturation. So its absorbing capacity is less. So when it absorbs less amount of moisture, it loses less amount of heat. When it is losing less amount of heat, the difference between dry bulb and wet bulb will be small. Thereby, the wet bulb depression will be small. Sir, did I get my job, sir? Yes. Kulkarni, you got a job and your salary is so and so. Thoko tali. वाह, सवाल बच्चे पूछ रहे, हिंदुस्तानी भाव, वाह वाह, नीतीश कुमार ने सही पूछा, मिस्टर पीके व्हाट इज वेट बल्ब टेम्परेचर, वाह क्या स्टूडेंट्स है रे, मेरे स्टूडेंट्स ऐसे ही रहते हैं, हीरे हीरे रहते हैं, वाह मजा आ गया, मजा आ गया सर, आग लगा देना रे, आग लगा देना रे, डिंग डिंग। चलो आगे बढ़े। वंडरफुल सर्स, लेट अस अज्यूम, आराम से, लेट्स नॉट वेस्ट अवर टाइम बिकॉज आवर मेन एम इज क्वालिटी, क्वालिटी। यस, अब देखो, सुनो सर्स, लेट अस से नाउ इट इज, देखो सर्स, इट इज वेरी इजी टू वेट बल्ब टेम्परेचर। यू टेक अ थर्मामीटर कवर्ड विथ वेट क्लॉथ, हो गया। दैट्स वाई इट इज एक्चुअली प्रॉक्सी फॉर रिलेटिव ह्यूमिडिटी, मतलब रिलेटिव ह्यूमिडिटी ओमेगा के प्लेस पे ये रिप्रेजेंट करा, बिकॉज इट इज वेरी इजी टू मेजर। दैट्स द रीजन। वंडरफुल सर्स, वंडरफुल। Okay, sirs? Yeah. Chalo. Now, let us assume that saturated air is flowing. Wait. Let the dry bulb temperature be some 32 degrees centigrade. Let us say the saturated, इसका temperature है 32 degrees centigrade, saturated air. अब saturated air flow हो रहा है, saturated air flow हो रहा है, सुनो, saturated air flow हो रहा है. Now you tell me, is there any chance for air to absorb moisture? Already it is up to saturation. When it is up to saturation, will it absorb? It will not absorb. It will not absorb. When it is not absorbing any more moisture, there is no need for my air to give heat. In previous case, why was it losing heat? Because it has to gain moisture. So in the process of gaining moisture, it is losing heat. So when it is not losing heat, it is not gaining any moisture, automatically there is an equilibrium. Automatically there will not be any drop in the temperature. When there is no drop in the temperature, the dry bulb and wet bulb are absolutely same. फिर से बता रहा हूं सर, why the difference between dry bulb and wet bulb is coming? Because it has less moisture, so it is unsaturated. If it is already saturated, अगर ये already saturated है, if it is already saturated, will it absorb moisture? No. When it is not absorbing moisture, it will not give heat. When it is not giving heat, automatically equilibrium is reached. प्रीवियस केस क्या हो रहा था, गिविंग हीट गेनिंग मॉइस्चर, ये हो रहा था, इसलिए देयर वाज अ ड्रॉप इन टेम्परेचर. नाउ देयर इज नो ड्रॉप इन टेम्परेचर, व्हाटएवर द ड्राई बल्ब इज देयर, माय वेट बल्ब इज आल्सो सेम. इसका मतलब क्या है, whenever the air is saturated, whenever the air is saturated, my dry bulb is equal to wet bulb. देखो, wet bulb is same. And what is wet bulb depression? WBD का मतलब wet bulb depression. It is the difference between dry bulb and wet bulb temperature. When both temperatures are same, when both these temperatures are same, so wet bulb depression for saturated air, the wet bulb depression for saturated air is 0. कल ये भी देखे थे, for saturated air what is the relative humidity? It is PV by PVS. Whenever it is already saturated, if it is already saturated, my PV will be PVS. So therefore it is equal to 1 or 100%. So दो चीजें याद रख लेना. For saturated air, not only the relative humidity is 100%, the wet bulb depression is 0 and the dry bulb and wet bulb temperatures are same. Are we clear, my dear students? बोलो बोलो, वाह क्या स्टूडेंट्स है रे, अच्छे पढ़ रहे, देखो ये होता है सर. Wonderful sirs, wonderful sirs, wonderful. Now we have seen two temperatures, one is dry bulb, one is wet bulb. Great sirs. So these two temperatures are measured by what? Psychrometer. What is that? Psychrometer. And this psychrometer we call it as sling psychrometer. So psychrometer has how many thermometers? Two. One is for dry bulb, one is for wet bulb. Leave it. ये हो गया सर, यहां तक किसी को कोई प्रॉब्लम नहीं है। अरे डॉक्टर धीरज आ गए, डॉक्टर धीरज किशोर जोहर, वेरी गुड। नाउ आगे बढ़े सर। सो लेट्स प्रोसीड नाउ। द फोर्थ वन इज, ओ माय गॉड, व्हाई इज इट फोर्थ वन? इट इज फिफ्थ वन। व्हाई सर? रिलेटिव ह्यूमिडिटी, स्पेसिफिक ह्यूमिडिटी, ड्राई बल्ब, वेट बल्ब, फोर्थ तो हो गए। नाउ फिफ्थ वन, एंड फिफ्थ वन इज ड्यू पॉइंट टेम्परेचर। सर्स, जैसे ही मेरा क्लास होता है, ऑन द सेम चैनल आई मेड वन वीडियो दैट इज वेट बल्ब टेम्परेचर एंड ड्यू पॉइंट टेम्परेचर का। हो सके तो उसको देख लेना और आपको कुछ क्लैरिटी आ जाएगा। सो हाउ इट्स रेनिंग, व्हाट इज द फिनोमिनन ऑफ रेन, ऑल दोस आई हैड एक्सप्लेन। तो होने के बाद इसी चैनल पे, मैकेनिकल का फंडा के चैनल पे, आई हैव मेड ए वीडियो ऑन वेट बल्ब टेम्परेचर एंड ड्यू पॉइंट टेम्परेचर। एक बार वो देख लेना। रिलेटिव ह्यूमिडिटी, वेट बल्ब टेम्परेचर का बनाया। अगर आपको इंटरेस्ट है तो ही देखना। आई एम नॉट फोर्सिंग एनीवन। मैं आपको शेयर करो, लाइक करो, ठोको ताली, ये नहीं बोलूंगा सर। Simply I say, if you are interested, I have given you information. No problem at all. My aim is to deliver the content. Rest you have to do. What is dew point temperature? Sirs, what I have done is, I have taken 2 bottles from refrigerator. I have taken 2 bottles from refrigerator. This bottle was kept in freezer. एंड दिस वॉज इन रेफ्रिजरेटर, नॉर्मल रेफ्रिजरेटर में। और ये ज्यादा क्या बोलते हैं, ज्यादा देर नहीं रखा गया था। इट वॉज नॉट केप्ट फॉर अ लॉन्गर टाइम, बट दिस वॉज केप्ट इन फ्रीजर फॉर अ लॉन्गर टाइम। नाउ कैन यू गेस, एक सेकंड प्लीज। क्या बोलते हैं sir, when we say temperature of a given area is T? Very good. Someone said, sir, if the temperature is given as T, he is not saying any other temperature. If no information is given, simply he says the temperature at a particular place or particular area is T, it is dry bulb temperature. It is just dry bulb temperature. If no information, you see, every time there is no need for him to give dry bulb temperature. If nothing is added before the temperature, it means it is dry bulb temperature. Hope I have answered. Is this okay, sirs? Yes, very good. Yes, suno, sirs. Please suno. Now air is flowing. Air is flowing. You tell me, as this is taken out from the freezer, the surface temperature of this bottle is very low. And the surface temperature is low, but not that low. अरे यार, compared to air, because it is taken out from the refrigerator, its temperature is low compared to air temperature. But compared to this is at lower temperature. You may be wondering, you will be seeing some water droplets, but you don't see water droplets on this. Matlab, there must be something, sirs. The same thing I have told you. You go for a morning walk at 5:30 in summer, at 5:30 in winter. In winter on grass, you will be seeing some dew formation. But in summer, you don't see. Same phenomenon, same concept. This is like summer and this is like winter. इसका मतलब है, there is some temperature at which water vapor in air is condensing out. Let me tell you, sirs. कुछ मत करना सर, इधर देखो. Don't do anything. I have not defined what is dew point temperature. I have not defined, sirs. एक पॉइंट बताता हूं, सुनो. Conceptually जाएंगे, sirs. Now, what is this temperature, sirs? Obviously, this is dry bulb temperature. Correct. This is partial pressure of vapor. So what do you mean by partial pressure of vapor? You have air In that air, there is water vapor, there is dry air. So whatever the pressure of vapor is exerted in the total mixture, we call it as partial pressure. We call it as partial pressure. Idhar dekho. Now there is a bottle. Look at sirs. There is a bottle. Air is flowing over the bottle. There is a bottle. Air is flowing over the bottle. Are you changing the pressure, sirs? Are you changing the pressure? No, sirs. I am not changing. At a constant pressure, it is flowing. At a constant, see, if the surface temperature of this bottle is very cool, if the surface temperature of this bottle is very cool, air is coming. One, it is at constant pressure. My pressure is not changing. So atmospheric hai. So in that PA plus PV, it is constant. So air is flowing. So क्या होगा मैं बताता हूं. When it comes in contact with colder surface, its temperature will drop. But is the pressure changing? No, sirs. In wet bulb temperature, what was happening? You know, it was gaining moisture. In the process of gaining moisture, its partial pressure of vapor was increasing. That's why it was moving like this. It was moving like this. But now, look at sirs. What is the state of this, sir? Can I call this as a superheated vapor? Can I call this as superheated vapor? Bolo re, can I call this as superheated vapor? Yes, it's all superheated vapor. Now let this dry bulb temperature be some 30 degrees centigrade. बहुत carefully सुनना sir. I am cooling at a constant pressure. Let us say I have cooled from 0.1 to 0.2. What is the temperature at 0.2? Listen, sirs. What is the temperature at 0.2? Let us say it is 25. Still that air is in what state? Superheated state. Still that air is, water vapor is in superheated state. So you don't find any moisture. So what is happening, my dear students? Ab aap bataunga, sirs. What is happening, my dear students? In summer, even though you are decreasing the temperature, it's not that low. In summer, morning temperatures are not that low compared to morning. And this is another bottle. So this is something like this. देखो यहाँ पे तो air is coming, its temperature is somewhere here. That's why it is just cooling without forming any moisture. Now you cool it further. अब समर के मॉर्निंग लोअर टेम्परेचर से धीरे धीरे विंटर में आ जाना. सो समर मॉर्निंग टेम्परेचर्स आर लेट अस से अराउंड 22, 23, 22. But winter morning temperatures are around 8 or so. So once it देखो at a constant pressure you are cooling. देखो air is flowing over this surface. Its pressure is not changing. इसका pressure change नहीं हो रहा. धीरे से आ रहा है देखो. आके once it touches this point क्या होगा सर अब? So it has reached saturation. अब इस point से Now, अब वो ये रीजन क्या है सर? लिक्विड प्लस वेपर. ये क्या है? लिक्विड वेपर. इट इज वेपर, इट इज लिक्विड. तो वंस इट टचेस एंड फर्दर कूलिंग, ये टच करने के बाद अब धीरे से वाटर वेपर स्टार्ट्स कंडेंसिंग. सो व्हेन यू आर कूलिंग and when it touches this point, then the moisture starts coming out. Then water vapor starts condensing. That's why in winter, as morning temperatures are lower than this temperature, अब इस temperature को हम बोलेंगे dew point temperature. So what is dew point temperature? It is the temperature at which water vapor in air starts condensing. जब air condense होना शुरू, water vapor condense होना शुरू करेगा, जिस temperature पे वो condense होना शुरू होता है, the temperature at which it starts condensing, we call it as dew point temperature. So if the temperature is above dew point temperature of air, there is no condensation, there is no water droplet formation. That's why in summer, even though morning temperatures are low, but they are not lower than dew point temperature. That's why you don't find any condensation. But in winter, as the temperatures are very, very low, it touches that dew point. Once it touches dew point, it starts condensing. So this particular temperature at a constant pressure when you are cooling, when it touches this and that particular temperature, you call it as dew point temperature. To attain dew point temperature, it should be cooled at a constant pressure. Please बताइए सर, आप लोगों को समझ में आया? Have you followed रे? क्या स्टूडेंट्स है रे? आप भी नमूने निकले रे. ऐसा मत करो रे. एकदम क्लियर है? वेरी गुड सर, वेरी गुड, वाह। नाउ देखो सर, तो इंटरव्यूज में पूछेंगे व्हाट इज ड्यू पॉइंट टेम्परेचर। एक ऐसा टेम्परेचर है जहां से जो वाटर वेपर एयर में है वो कंडेंस होकर लिक्विड में फॉर्म होना शुरू होता है। इट इज वन सच टेम्परेचर एट विच वाटर वेपर इन एयर स्टार्ट्स कंडेंसिंग। तो इफ यू वांट कंडेंसेशन, इफ यू वांट रिमूवल ऑफ मॉइस्चर, मतलब एयर से अगर मॉइस्चर को निकालना है, इफ यू वांट टू रिमूव वाटर वेपर फ्रॉम एयर, इट शुड टच this temperature. If it is not touching this temperature, simply cooling, you may be reaching here. If you reach here, still it is in superheated state. Still it is in superheated state. There is no question of condensation. So if you want to remove water vapor from air, it should touch dew point temperature. So hope it is clear, my dear students. एकदम clear है sir. Very good. Now, sir, एक बार टच होने के बाद तब सिचुएशन विल बी डिफरेंट। यस, तब देखो मैं एक बहुत अच्छा क्वेश्चन पूछा सर, निरंजन हैज आस्क्ड अ वेरी गुड क्वेश्चन। मत उनका क्वेश्चन मैं उनके क्वेश्चन को कल आंसर करूंगा सर, विद द हेल्प ऑफ साइक्रोमेट्रिक चार्ट। यस, यू आर राइट। मैं आपको आपके क्वेश्चन का आंसर कल दे पाऊंगा सर, क्योंकि व्हेन आई टीच साइक्रोमेट्रिक चार्ट, इधर देखना, वहां पे मैं ऐसे बताऊंगा, देखो ऐसा आके कुल होके ऐसा होगा, ये सब मैं बताऊंगा सर। निरंजन आपका नाम लेके बताऊंगा। यस सर, यस, वो भी फिजिकली बताऊंगा। डोंट वरी सर, डोंट वरी। यहां तक सभी को क्लियर है सर? बोलो रे, यहां तक सभी को क्लियर है रे? नाउ देखिए, if it is clear then I'll proceed. If it is clear then I'll proceed. अगर ये क्लियर है तो मैं आगे बढ़ूंगा। अगर ये क्लियर है तो मैं आगे बढ़ूंगा। बोलो यस यस यस। ग्रेट धीरज कुमार, थैंक यू थैंक यू थैंक यू धीरज कुमार, थैंक यू, गॉड ब्लेस यू, गॉड ब्लेस यू। So it is the gratitude, it matters. It is a gratitude. Thank you, sirs. Thank you, Dheeraj Babu. Now, let's see the beauty, sirs. अब देखेंगे रे, मजा देखेंगे रे। सुनो carefully. खुशियानी, what is this? Dry bluff. Great. Now, anyone? Wet bluff. At a constant pressure, we are cooling. It is reaching saturation. And this temperature, you call it as dew point temperature. Oh my God. When there is unsaturated air, it is unsaturated only because this is saturation. For unsaturated air, dry bulb is greater than wet bulb and wet bulb is greater than dew point. So for unsaturated air, dry bulb is greater than wet bulb and wet bulb is greater than dew point temperature. आप बताइए सर, is it clear? Dear students, is it clear? बोलो सर जी, बोलो बाबुलू। Great. Now, ये हो गया सर। Let us take saturated air. Instead of unsaturated, let us take saturated air. Let us take saturated air. So neatly करेंगे सर, चिंता ना कर तू, चिंता ना कर, neatly करेंगे। क्लियर, वेरी गुड। आप लोगों का कमेंट नहीं आता रे। When a teacher is struggling for your cause and you people are sitting happily chips खाते हुए ऐसा सोफे पे बैठे हुए, ऐसा नहीं होता सर। अगर पढ़ाई करना है तो सिंसियरली करो, नहीं तो मत करो। Let us say there is a saturated air. Dear students, Dear students, देखो carefully. Previously it was unsaturated. Previously it was unsaturated. So I have shown here. Now it is already saturated. It is already saturated. So where do I show? If it is already saturated, ये होगा. अरे यार इनिशियली मतलब अनसैचुरेटेड था तो यहां पे था, तो अब ये डायरेक्टली ड्राइबल हो गया. अब बताओ सर वेट बल्ब कहां पे होगा? वेट बल्ब कहां पे होगा? सेम होगा ना. इधर देखो, एक सेकंड रुको. सो लुक एट माय डियर स्टूडेंट्स, इट इज कूलिंग कमिंग टू हियर. सो ऑलरेडी आई टोल्ड यू दैट, मैं ऑलरेडी आपको बता चुका हूं, व्हेन एयर इज सैचुरेटेड, what is dry bulb and wet bulb? When air is saturated, what is wet bulb and dry bulb? I have told you that for saturated air, wet bulb depression is 0. For saturated air, wet bulb depression is 0. So therefore, dry bulb is equal to wet bulb. अगर ये dry bulb है, तो it is also equal to wet bulb temperature. अब आप बताइए sirs. Now you know where will condensation begin when it reaches saturation state. Already it is at saturation state. When already it is at saturation state, यहीं से ही condensation शुरू होगा. So previous case, dear students, previous case it was away from saturation. That's why after reaching saturation, it is undergoing condensation. But already it is at saturation. So when it is already at saturation, it will start condensing at this temperature only. That itself is your dew point temperature. So therefore, for a saturated air, all these three temperatures are same. For saturated air, all these three temperatures are same. Are Baba, are we clear? Lucifer, Babu Lucifer, Babu Lucifer. So therefore, now let me write one golden sentence. For saturated air, relative humidity is 1 or 100%. Then देखो समझ में आया ना? Then क्या होगा सर? Dry bulb is equal to wet bulb is equal to dew point temperature, and wet bulb depression is equal to dry bulb temperature minus wet bulb temperature, and that is equal to 0. So this is for saturated air. Is it clear? Anything more? Wonderful. Hope these temperatures are clear, dear students. Hope these temperatures are clear. Clear हुआ? Clear है? Everything is smooth. Thank you. So we have seen omega, phi, relative humidity, specific humidity, relative humidity, dry bulb, wet bulb, dew point temperature. Now let us see the next parameter. So shall we see or shall we stop? आप बताइए sirs, continue करूं या stop करूं? आप बताइए रे. Shall I continue or shall I stop? Top of the world. बोलो, आप जो बोले वो करते हैं. कंटिन्यू. वाह, बहुत ही अच्छे स्टूडेंट्स हैं. हाँ, नेचुरली हुआ, हम नहीं किए, वो नेचुरली हुआ. हम आर्टिफिशियल भी कर सकते हैं सर, कोई दिक्कत नहीं. चलो आगे बढ़ते हैं. So hope my voice and everything is clear ना? So कोई टेंशन नहीं ना? Yes sir, continue. Top of the world. He is always on the top of the world. So continue. Okay, चलो. Enthalpy of moist air. Dear students, in thermodynamics we have ये बहुत इंपॉर्टेंट है सर. This is very important. This is very important. So I'll give you with logics and concepts. मैं सारे concepts के साथ बताऊंगा. Look at now enthalpy of moist air. क्या हुआ? सही है ना? सब कुछ सही है? Is everything fine? Okay. Hope everything is fine ना? चलो, okay, no problem at all. चलो आगे बढ़ते हैं सर. Let's proceed. Now, in thermodynamics we have seen there are extensive properties and there are intensive properties. For example, let us take a system. Let this volume be V1 and this volume be V2. What is the total volume of the mixture? Already I told you. In thermo, I taught you very clearly. So if you want the total extensive property, volume is an extensive property. If you want the total extensive property, it is equal to sum of the individual extensive properties. For example, this volume plus this volume will give me this volume. So this we have seen with respect to anyone. This we have seen with respect to waters. This we have seen with respect to extensive properties. Whenever you want total extensive properties, it is the sum of individual properties. For example, let us say यहाँ का temperature है, यहाँ का temperature है. What will be the temperature? It will be same. Even if you partition, it will be same. I cannot add this. Intensive properties are not added. Extensive properties are added. And in thermodynamics, I taught you beautifully why enthalpy is an extensive property. मैं extensive नहीं बोला, why बोला है. So, and one more thing, I have made a beautiful video on enthalpy. If you want, you can watch that also. I'm not asking you to watch. If you wish, you can watch. On this mechanical का फंडा, you have got some beautiful videos made by me. आप देख सकते सर, all practical, and many more are coming in future. देखो. So why your teacher is saying like this? There is a reason. Why I am saying like this? There is a reason. The reason is अब आएगा देखो. अब देखो सर, बहुत इंटरेस्टिंगली देखेंगे हम. देखो सर, let us take air. Whenever I say air, it is actually moist air. Means in that air you have dry air and water vapor. Let us assume that there is some mass of vapor and there is some dry air. Please note down that it's not separate. तो कंफ्यूज हो गए होंगे शायद आप. So please, it's not separate, it is uniform. तो इसको हटा दूंगा सर. I'll remove this. Now there is some water vapor. This is known as moist air. Now my aim is to find out the enthalpy of this moist air. Let me repeat sir. मेरा aim है इस air का enthalpy find out करने के लिए. So what is this air? It is a moist air. Great. Let H be the total enthalpy of moist air. And everyone knows enthalpy is an extensive property. If you want extensive property, it is sum of the individual extensive properties. So if I want the total enthalpy, it will be enthalpy of dry air plus enthalpy of water vapor, because it is an extensive property. अगर total extensive property चाहिए, so therefore can you tell me what is capital H? It is the enthalpy of moist air or air. So it is equal to sum of the individual enthalpies. Okay, clear? Sum of the individual enthalpies. Okay, no problem, sirs. यहाँ तक किसी को problem नहीं. Why are we adding? Because enthalpy is an extensive property. Leave it. देखो, वही अगर इंटेंसिव है तो क्या बोले थे सर? Temperature of vapor is equal to temperature of dry air is equal to T बोला था. So I told. So whenever it is intensive, it will be same. But extensive, you have to add. All this I had taught you beautifully in thermodynamics. Now, let's see what is specific enthalpy. Specific enthalpy is total enthalpy per unit mass, or total enthalpy is equal to M into H. So can I write? If you want the total enthalpy of moist air, it will be HA plus HV. What is HA? Dekho sirs, can I write enthalpy of dry air as mass of dry air into enthalpy of dry air, specific enthalpy, and can I write enthalpy of vapor as mass of vapor into specific enthalpy? Can we write capital HA is MAHA, capital HV is MVHV? Yes. So what is this? H is enthalpy of dry air, that is HA plus HV. What is HA? MAHA plus HV. What is HV? MVHV. Absolutely fine. And I taught you very clearly, in air conditioning, all calculations are based on fixed part, that is per kg dry air. Which one is fixed part, dear students? Which one is fixed part, my dear students? Which one is fixed part? कौन सा fixed part है, आप ये बताइए. कौन सा fixed part है? Dry air. That's why what we do is, देखो एक बार, H is equal to MAHA plus MVHV. Now divide with MA. Divide both sides with MA. यहां पे छोटा सा कंफ्यूजन हो सकता है. Can you tell me what is capital H? Capital H is nothing but it is the total enthalpy of moist air, which is a combination of dry air and water vapor. So please note down that एंड इसको मैं लिखूंगा, दिस आई राइट इट एज स्मॉल h. डू नॉट गेट कंफ्यूज. स्मॉल h इज व्हाट? It is the total enthalpy. This is my small h, sir. Small h is the total enthalpy of air measured with per kg of dry air. आप confuse मत होना sir, confuse मत होना. Let me explain again. You know that capital H is HA plus HV. तो कैपिटल H में क्या क्या है बोलो? In capital H, what do we have? Enthalpy of, in this capital H, there are two things, dry air and water vapor. So can I say this capital H as total enthalpy of moist air? Yes, it is the total enthalpy of moist air. But what is small h? Total enthalpy divided with mass of dry air. Why are you dividing with mass of dry air? Because in air conditioning, all calculations are based on per kg dry air. Capital H is expressed in kilojoule and MA, it is mass of dry air, so many kg of dry air. So please note on that. It is not the enthalpy of dry air. This H is not the enthalpy of dry air. It is the total, small h is the total enthalpy of air expressed per kg of dry air. So इस H में everything is included, dry air and water vapor. So can I write this as small h is equal to, see capital H by MA is small h, small h is equal to MA cancel करो HA. What is MV by MA? कल देखे थे, yesterday we saw mass of vapor to the mass of dry air is specific humidity omega. So therefore this is omega. MV by MA is omega into HV, and this is the enthalpy of moist air. Please listen carefully. Where HA is specific enthalpy of dry air, HV is specific enthalpy of water vapor, and H is total enthalpy of moist air per kg of dry air. So I will take this equation. अरे हम तो फकीर है, ये इक्वेशन लेके चल पड़ेंगे. अब आगे देखो, इस इक्वेशन को लेके आगे चल पड़ेंगे. सो H इज इक्वल टू HA प्लस ओमेगा HV. अरे बाबा, आर वी क्लियर? नहीं आया सर? ओके सर, ओके सर. वेरी गुड सौम्यदेव, क्लियर टिल हियर. गैलेक्टिक, अच्छा, गजब गजब का है दिन, सोचो जरा. चलो, वंडरफुल स्टूडेंट्स ऑफ इंडिया. अब सवाल उठता है, कैन आई राइट दिस एज इट इज द टोटल एंथैल्पी ऑफ मॉइस्ट एयर एक्सप्रेस्ड पर kg dry air. Wonderful sirs, wonderful. अब देखो, एक गोल्डन पॉइंट बताऊंगा, जस्ट लिसन टू मी. सो आफ्टर कवरिंग दिस विल स्टॉप फॉर टुडे. देखो, whenever you are measuring energy levels, you should always have a reference level. You should always have a reference level. You should always have a reference level. At some point, I will say the energy is zero. From there, I'll measure. For example, I measure potential energy. So here I assume to be zero. With respect to this, the potential energy of this is so and so. Means arbitrarily you assume. But now the question that comes is, sir, will it not affect? In thermodynamics, we are always interested in difference. Process. Process is change of state. Whenever there is a change of state, for example, reference ये है. So ये 1 है, ये 2 है. मान लो. This is, let us say, H1. And this is, let us say, H1, H2. अब मुझे बताओ, is the difference between these two has any effect on this datum? Whether you take this datum or whatever may be the reference, the difference is not going to change. That is the logic here. So I will take some arbitrary reference, random datum, reference. Is it clear? So समझ में नहीं आया. अरे यार, what I am saying is, whether I want the difference between these two. When you want the difference between these two, whether I measure from this or this, what will be the difference between these two? Individual values may change, but the difference is not going to change. So we are not interested in individual values because we are interested in a process. For a process, we are always interested in change of state. Whenever there is a change of state, क्या होगा? अगर यहां से measure कर रहा है, तो this, again I get this difference. So therefore, this datum has no problem. This datum has no problem at all. So that's why I take arbitrary or random reference. So my dear students, यहां पे एक छोटा सा प्रॉब्लम है सर. Here there is a small problem. The small problem is I have to take a separate datum for dry air. I have to take separate datum for water vapor. Let us take enthalpy of dry air. That is HA. Look at carefully. Dry air is an ideal gas. We can treat it as ideal gas. For an ideal gas, what is the enthalpy? CPT. So therefore, I write it as CPT. Enthalpy for ideal gas can be written as CPT. अब देखो, ध्यान से सुनो सर. At 0 degree centigrade, the enthalpy of dry air is randomly, arbitrarily assumed it as 0. Now you may be asking a question, sir, why is it taken as 0? Arey yaar, I said reference can be anything. Arey, if you are not happy with this, you take your own reference. But you will get the same answer because I am interested in difference. Complete world is taking this reference, so I am giving you this reference. So what is the reference for dry air? The enthalpy of dry air at 0 degree centigrade is taken as 0. Now, what is the temperature of our air? It is the dry bulb temperature. What is the normal temperature of air? It is the dry bulb temperature. It is not 0. It is something here. Let us say our air temperature is, our actual air temperature is T. So I want the, with this reference, इस reference से मुझे मेरे air का, dry air का enthalpy चाहिए. अरे यार, फर्स्ट ड्राई एयर का फाइंड आउट करेंगे, देन वाटर वेपर का फाइंड आउट करेंगे, देन विल पुट हियर एंड यू विल गेट द एंथैल्पी ऑफ मॉइस्ट एयर. बट दिस इज एक्सप्रेस पर केजी ड्राई एयर लिमिट. अब यहां से मुझे इसका एंथैल्पी चाहिए, तो कैसा करेंगे सर? नाउ एंथैल्पी ऑफ ड्राई एयर, इधर देखो, सीपीटी, सीपीए, इस रेफरेंस से इस, व्हाट इज द डिफरेंस? इट इज टी माइनस 0. नाउ वन स्टूडेंट सेड, सर व्हाई आर यू नॉट टेकिंग केल्विन? यू सेड इन आइडियल गैस इट शुड बी टेकन इन केल्विन. ना, are in namune, it is the difference. Whenever it is difference in temperature, it doesn't matter whether it is in Kelvin or degree Celsius. चलो आप Kelvin ले लेना. अगर Kelvin की बात कर रहे हैं तो ये होगा 273. 0 डिग्री सेंटीग्रेड मींस ये 273 और ये क्या होगा? T plus 273. Now you calculate the enthalpy. It is equal to CPA and देखो T plus 273 minus 273 ये होगा आपका. So that's why, as it is difference in temperature, it doesn't matter whether it is, again you get the same thing. It doesn't matter whether it is in centigrade or Kelvin. So therefore, enthalpy of dry air is given by specific heat of dry air, T minus 0 is T, where T is dry bulb temperature in degree centigrade. Why degree centigrade? It is actually not T, it is actually T minus 0. डिफरेंस है यहाँ पे. ये अगर ये सेंटीग्रेड में है तो ये भी सेंटीग्रेड, अगर ये केल्विन में है तो ये भी केल्विन में होगा. सो अगर केल्विन में चाहिए तो T plus 273, 0 means to T plus 273. So it is difference. So I write CPAT where T is dry bulb temperature in degree centigrade. Confuse मत होना. Enthalpy of dry air is given by specific heat CPA into T, where T is actually it is T minus 0 because this is the reference. So as this is in degree centigrade, this should also be in degree centigrade. So T minus 0 is T. So enthalpy of dry air is CPAT, where small t is dry bulb temperature in degree centigrade. Degree centigrade. Is it clear, sirs? नहीं बोल रहे सर, आप कुछ नहीं बोल रहे सर. You are not seeing anything. Very good. तो ये आ गया, तो इसका वैल्यू आ गया सर. What is HA? It is CPAT and the specific heat of air is 1.005. ये आ गया. So ये this will be known to me. This is already known. And T is dry bulb in degree centigrade. Dry bulb in degree centigrade. I am shouting. I know the reason. Now let us calculate enthalpy of vapor. अब देखो सर, लास्ट, अब आज के लिए बस इतना. Now I'll write enthalpy of vapor. देखो, for vapor, देखो, this is taken as the reference. For dry air, 0 degree centigrade is taken as reference. Here also 0 degree. But किसके लिए 0 degree? 0 degree सैचुरेटेड लिक्विड. तो यहां पे हम एंथैल्पी लिक्विड का, वेपर का 0 मानते हैं. लेकिन हाउ इज वाटर वेपर एग्जिस्टिंग? वाटर वेपर इज इन सुपर हीटेड स्टेट. हमारा वाटर वेपर कहीं पे है, देखो, इट इज समवेयर. सो दिस इज द ड्राई बल्ब टेम्परेचर. वाई माई वाटर वेपर इज समवेयर हियर? तो इस रेफरेंस से मेरा वाटर वेपर इज समवेयर हियर. दिस इज द ड्राई बल्ब टेम्परेचर. सो दिस इज माई 0 डिग्री सेंटीग्रेड. तो आपको क्या करना है सर? विद दिस एज, ये तो आर्बिट्ररी रेफरेंस है, दिस इज द रेफरेंस. इस रेफरेंस से इसका एंथैल्पी फाइंड आउट करना है. बिकॉज माई वाटर वेपर इन एयर इज इन सुपर हीटेड स्टेट. मेरा एक्चुअल वाटर वेपर इस स्टेट पे है. तो यहां पे आर्बिट्ररली 0 अज्यूम किए, यू अज्यूम इट टू बी 0. तो इस रेफरेंस से आपको यहां फाइंड आउट करना है. इट मींस इस रेफरेंस से आपको लेटेंट हीट जाना है. दिस इज माई लेटेंट हीट एंड दिस इज द सेंसिबल हीट. तो ये हीट लेना है, ये हीट लेना है. तो विद दिस एज द रेफरेंस, इसका एनर्जी क्या होगा सर? सो एंथैल्पी ऑफ वेपर इज, दिस इज माई लेटेंट हीट प्लस this can be treated as ideal gas because it is in superheated state. So it is specific heat of vapor C delta T. This is T dry bulb temperature and this is 0. ये 0 है, ये 0 है, ये T है. Again it is T minus 0. So as it is 0 degrees, if this is in degree centigrade, this should be in degree centigrade. So again it is dry bulb temperature in degree centigrade. तो ये होगा आपका enthalpy of vapor is latent heat plus specific heat of vapor into T, where T is dry bulb temperature in degree centigrade. Generally at 0 degree centigrade the latent heat is about 2500 and the specific heat of vapor is about 1.88 kilojoule per kg Kelvin. So therefore the enthalpy of vapor is, please don't by heart these values, you remember this equation, because sometimes in examination he may be giving 2470, sometimes he may be giving this as 1.91. so whatever values are given you take. If those values are not given, just write these values. तो इसको लिखेंगे 2500 प्लस इसको लिखेंगे 1.88 T. so therefore now अब देखना सर, एंथैल्पी ऑफ मॉइस्ट एयर इज गिवन बाय HA प्लस ओमेगा HV. So already you know HA is CPAT. Already we have calculated. Plus omega times what is HV? 2500 plus 1.88 T, where T is dry bulb in degree centigrade. Please tell me, is the derivation clear? This derivation was asked 2 times in civil services mains examination. Is the derivation clear, sirs? Is the derivation clear, sirs? ये आप कुछ नहीं बोला सर, मैं क्या करूं फिर? पक्का? सो अब आपसे थोड़ा बात करूंगा. डू यू वांट मी टू कंटिन्यू दीज क्लासेस और स्टॉप? कल से बंद करें ये क्लासेस? See, whoever is coming, I'm not looking at the quantity, I'm looking at the quality. Whoever is coming, if you come sincerely, it will be better for you and better for everyone. Okay? चलो my dear students, तो फिर कल मिलते हैं with beautiful concepts, development of psychrometric chart, how psychrometric chart is developed, what are the various lines, how we draw various lines on psychrometric chart. Everything will be discussed to the best of your satisfaction. Thank you my dear students. God bless you. Love you all. Bye bye. Good night. Good night. And I taught already 12 subjects on Unacademy Plus, and you know the affection, the love my students have shown, I cannot express in words. 12 subjects at its best. For every subject I took maybe one year of preparation. So thank you my dear students for your affection, and I am coming up with some more new subjects. God bless you. Goodbye. Good night.